Hello and welcome back to my channel, Intelligent Institute of Education. If you haven't subscribed my channel, so please subscribe my channel, Intelligent Institute of Education. And if you have subscribed, so please subscribe in different devices because this is the most important for me, right? So today my session is that I want to explain bitwise operator. So far, already I have explained and already have uploaded all operators like arithmetic operator, assignment operator, comparison operator. So this is also called as relational operator, identity operator, membership operator, and today the last operator, bitwise operator, I'm going to explain, and inshallah today I will upload it, right? So please you revise a lot, and whenever you are going to face any problem, so please write in my comment section, so I will try to answer it. So before starting that, I want to first tell you what is bitwise operator and what are that, and actually what is the purpose of this, because already we are student of schools, colleges, universities, because this is the most important questions they will ask during examinations and as well as in interviews. Because the faculty members and as students, this bitwise operator, we can use very less, right? So this expected and importance will be high during examination and as well as in interview time. So let us see bitwise operator. So first bitwise operator, this is the base or binary digit. Like, so already we know that binary digit in the form of 1 and 0. Fine. So, so this bitwise operator, like we have that bitwise AND operator, bitwise OR operator, bitwise XOR operator, bitwise tilde, that is called complement operator, or also we can say NOT operator. Then bitwise right shift operator, bitwise left shift operator, and at the last moment, I will tell you the precedence, how this behaves in a programming while any expression is there, and we are going to use, so how this behaves and how which operation we have to perform first. Actually, whatever we will write in Python program, it immediately will get answer. But we have to know, we have to understand how this logic is working inside our system. Is this all right? So first of all, now I want to explain you the concept of what are the applications we are going to use while we can use bitwise operator in a program. Is this all right? So I want to say again and again, please practice a lot, and whenever you are going to face any problem, please write in comment section, and also this all details I'm going to describe in description. Okay, you can see and you can learn and you can implement in a program. So while I am explaining, so after this I will take you in practical session, Jupyter notebook. In that all I will explain you. First, let's explain, and we have to understand what are the applications we have. So when we can understand during examination and as well as interview time, we can answer it, right? So here basically data, the first application I am going to explain you, that is called data compression. So this bitwise operators can be used to compress the data, because this data like we are using and or, so it will convert in the form of 1 and 0. So data compressed and it will reduce the size, right? Second is that encryption. For example, we are sending any message, SMS, short message service, right? So whatever we are writing the message, so this message converting in the form of 1 and 0. So this is also the major role that is operators such as XOR can be transformed in the format that is called as a ciphertext, and this format is a very secure. So these all are the questions asked by the examiner. Then when we know that, so easily we can understand, right? Then our chances will be high for selection. Next, you can say that is called as a image processing. Fine. So this is used to manipulate the in the form of pixels, right? In the form of pixels using AND or XOR. So now there are different image processes there. So with the help of that technique, we can use like masking, blending, and threshold can be implemented during writing. We have to code. So when we know that, so we can use these all applications, right? Next, I want to tell you that is called a networking. So this also we can use in a networking area, networking domain for IP address. That is called as a subnet mask, right? So by using this bitwise operators such as AND or XOR, so this we can use in the form of IP address like subnet mask, and can be implemented, determine network boundaries, and that is we can say perform for IP address filtering. So this also in the networking area, this is a major role while you have to use bitwise operator, right? So next, I want to tell you that is called as a microcontroller programming. So this also major role for bitwise operator. We can use these operations for hardware peripherals. Like we can say that with the help of OR and OR operations, so hardware peripheral can be controlled and monitored with the help of these bitwise operators. Like, so this is the major role we are learning, right? And this also explanation I will write in description. Fine. And please should not, but last, I want to tell you one again application we can use that is called graphics programming. So this also a major role, like we are going to use face mask detection and some biometrics. So we can use in graphics programming, like we can use these pixels bitwise such as XOR and transformed by a more pleasing form. So these all are the applications we can use in a programming skills. Then we can enhance, and also our selection the criteria will be more. So we have to aware as a we are a student of schools, colleges, or universities. Like, so now, without our wasting time, I am going to share a screen with Jupyter Notebook. So in that we can understand some practical. So we can understand somewhat more, and we can use in a practical way, right? So let us see here. Now I am going to take here, like we can say m equal to 15 decimal number, okay? And n equal to like 10. So before explaining, I want to tell you what are the operations in this we can perform. It will be quite easy, right? So now I'm going to take multiple line comment, single dots, and here we can use like first here, first will be and bitwise operator, and next we have here second, that is called or and we can use single ampersand sign. Fine. And for or we can use, we can say pipe sign or vertical bar, right? Or bitwise operator. Fine. So now I'm going to copy and paste. So in this way we can save our time. Fine. Third one is there, that is called XOR. So for XOR, we can use this cap or exponent symbol also we can use. So this is called XOR, right? Bitwise operator. Next we have that is called fourth. This is called as not. So for symbol, we can use tilde, or also we can say the tilde symbol. Fine, this is the not, or also we can say negation. Fine. So bitwise operator. Next is there, that is fifth, we can say left shift. So this is the symbol of left shift, left shift, left shift, and here bitwise operator. And last, that is called a sixth, we have here right shift. So this is called, I'm going to write here, right, right, shift, right shift, right shift operator. Fine. And at the last, the seventh number, I will explain you the precedence, precedence, precedence of bitwise operator. Fine. So let's see here one by one, so we can complete this. Fine. So m equal to, I have taken here decimal 15, and equal to n is 10. So we can use here, like I'm going to take other variable. So we can use, and just a moment, I want to tell you here. Let's continue our session. So now I was explaining here bitwise AND operator. Let's start. So I have taken here m equal to 15 and n equal to 10. So this is in a form of decimal number. So now I'm going to apply here m, and this will be AND operator. So better I have to write here ampersand AND operator and n, right? So now I'm going to print here. So print here k, so we can get the, what is the value of k, right? So we got here C10. So this is internally what is happening, we are unable to understand. So better the thing is that what we will do, we'll convert into a binary format, and that I will explain you so you can understand somewhat more. Let us see here. So now I'm going to convert here print and m. Okay, so for binary, this is very simple. You know why? Because this is the Python. Simple, we can write here bin, and we can write here m. Fine. And also this I'm going to copy here, this m and n. Okay, fine. Now execute this. Now see here. Now we have executed here. First of all, m is 15, right? And so we converted here m15 means 0b. Basically 0b, this extension, this is called as a binary number. Fine. And this 15, this is called 4 times 111. This is clear. And this n 10, so this is called 0b, means we have converted into binary. So 1010. Fine. So now here, we have to perform this AND function. So already we know, and also you can go through like my logical operator. In that I explain more. Okay, so if I will explain here, so my class will be long, so I don't want to make long class here. So here 10, right? 10 will be 0, 11 will be 1, and 10 will be 0, and 1 will be 1. So this, when we have performed this, so answer we got here in the form of 10. And 10, so better I will convert into this k in binary, so it will be somewhat easy. You can understand this. Okay, let me convert this k also, k, and now execute this. So now see here. So we got here 1010. Fine. So 1010, we can write the answer here in, that is called decimal here, 10. Is this clear? See once again, the this AND operation 1040 means here the AND both condition will be true. If anyone, then it perform here 0. 10 here 0, 11 here 1, 100 and 1 here 1. So we got here binary 1010. For this we can send decimal, that is called as 10. Okay, again any doubt, you tell me that. Next, I'm going to copy this and I will take one cell and I will perform here OR function. Fine. Let me write here so you can understand also more. This is called as a or bitwise operator. Bitwise operator. Fine. So in place of OR, we can use here pipe symbol, right? This is called vertical bar also. So now we can see here, M is 15 and N is 10 here, right? So now I'm performing this printing here value of K, and M also converting into binary and also converting, and K, the result also converting, so we can understand. Let's execute this program. Now see here. Now finally K result is 15. So I have converted M. So M 15 converted here 4 times 1 and 10 converted 1010. And in this we have applied OR, bitwise OR. So now we can see in this OR operation, any one condition will be true, then it perform here 101. Okay, 1 1 in both true, so here true. Again here 1 0 1 1 1 1. So it means that this is the all or fourth is true. So this fourth times true, so in decimal we can say 15, right? Now again I am going to copy this and I will use here, take the new cell, paste it here. So in this I will try to use here XOR. Okay, so XOR we can use here, this is the cap symbol. Fine, we can use this, execute this. See here, now what is the answer we got here? Fine, we got here first K and applied M. This is the symbol that is called XOR N. So printed here K. So we got here 5. So how this works? Because in programming easily converted internally. Fine. And we can understand this with the help of logic. Fine. So now bin M here 4 times 1 and 1010 we applied here. What is the concept of XOR? So concept of XOR means when similar, when both will be false or both will be true, then you can get false. And that is called as any true or any false. Then we can get here true. Like see here, 1 0. It means that one is true, one is false. We got here 1. Now both true, we got here 0. Right? 1 0, we got here 1. And both 1, that is called as a false. Fine. So here printed here 101. So basically 101 in decimal we got here 5. Is this clear? Now two more functions and then I will close this. Now let's copy this and we'll move to the next cell. Next cell. Here I will use here not, that is called not, and this we can use like I'm going to use n here comment, and here this also I'm to use here comment. Basically I can use here like k equal to like tilde symbol, no negation, here 15. Fine. I will print here k and m is okay binary, n we are not using, so better make here comment, and k I'm using, right? So run this here so we can understand. Now see here. So here this 15 we got here minus 16. How this work, how internally functioning, let me explain. I will explain you here. Now let us see here. For 15, so I will try to use 1 minute. This one. Fine. Let us see here. And I will check the color. Okay, red color. Fine. So now for 15. So for 15, we got here, like we can say 1, 1, 1. Okay. Now this is 32-bit representation, right? So you got here 4. And remaining will be like here left hand side, this all bit. Fine. So this will be all 0 0. Fine. Okay. So while this converted into negation not, so it became here this, now this. this one became this 0, or also I will try to write here. This is 0 here, this is 0 here, this is 0 here, and this is 0 here. Now, this is called by default here positive. This 0 represents positive. Now, this converted here, it became here 1. It means that negative. So, when it will be negative, then it represent here minus. Okay. Now, so when it became this negative, so this is not a final result here 0 0 0. So now internally it will convert into 2's complement. So now we'll see how it convert 2's complement. Fine. So first it convert here this all 0, it convert into negation. It means that it will become here 1. Now I want to convert 2's complement. This one, this one, this one, and this one. This is called 1's complement. And in this, what we'll do, we'll add here this one. Fine. So while we are going to add 1 plus 1, 10, it will be 0 here, and carry will be left hand side. Again, 1 plus 1, 0 will be, and carry will be here. 1 plus 1, 0, and carry will be here. 1 plus 1, this is called as a 10. Okay. And this is called negative. Already negative symbol will be here. So now we can see this is the answer. 1 4 times 0, and these are negative, and this while we are going to convert into decimal, so final answer will be minus 16. Is this clear? Any doubt? Please write in that. Now last operation I want to tell you. I have to move this. Now I am going to copy this, okay, and paste it here. So I will do what I will do. I will remove this one. I will try to remove, clear all drawings. Okay, now finish this. Now remaining 2 operations, then this will be finished. Now here I will use left shift, left shift. Okay, this is called left shift, bitwise operator. So now M is 15, and here K I'm going to use like here we can say left shift means I can write here M, and this left shift, and left shift 2-bit I want to move. Okay, so what it will work here, M, this I'm going to remove this one. Fine. This K, printing the value of K here, the binary conversion of M and K, this also N I am going to remove this. Fine. Let's execute here this. So final result is here 60. Now while we converted this M became here 60, I will explain you how we came here 60, and this 2 times converted here 2 bits. Let's check here. So now I'm going to take the board, in that I will explain you, we can understand more. Like see here 4. No, so I'm going to write here now 4. 4 ones, and basically this is moving here left side. Fine. So now how it will move here left side? So this one, it moved here left side. Okay. This one, this moved here left side. Okay. This one, this moved here left side, and this moved here left side. And here this, it became here this 0, 1 0. Okay. And again this moved here, and this moved is here. This one moved like here, and this moved here. So now this will be here, and this 0 shifted here, and again this is the empty, we are going to use 1 0 here. Okay, so now this is the 2 times. So now see here 4 times 1 and this 2 0. So answer is 4 times 1 and 2 0. So basically we can say this is multiplied by 2. It means that this is a 15. When 15 multiplied by 2, so this is the 30. This is the 30 means this is the answer will be 1 1 1 1 and 0. So this is called as a 30. Okay, and this again moved here 1 bit more left side. So here 4 times 1 and double 0. So this become here 60. So final result is 60. So we can say this left shift while we are moving, so multiplied by 2. So before it was 15, multiplied by 2, it became here 30. Again, multiplied by 2, it became here 60. Right? Last, I'm going to this erase this all, finish, and this last operation I'm going to perform. Then my session will be finished. So this will be the right shift. Okay, this is the right shift. So while right shift, then I have to change also the symbol. This symbol, this is called this. Fine. This is symbol. So now symbol here also everything will be same. Now I am going to change the symbol. This symbol will be this two times. While I am going to execute. So this answer is 3. So I will explain you how this answer is 3. Let's see here. Let me take here board. From the board I can explain you here like say 15. So this is the 4, okay, and this we have to shift here right hand side. So now this first bit, while this moving this one, it means that this is the outside going. Now the second bit will come the position of first bit, third moving here position of second, and then fourth moving position of third, and in place of fourth it occupy here 10. Fine. So I have written here shifted by 2 bit. Again, the right side, this is when shifting, so this is going outside. So this is the second bit occupying here first place, third occupying here second place, and this 0 is coming here in place of third. Again, this empty here 10 will come. So final answer is see here 11. So now this is the 11 answer is here. So like we can say this is divisible by 2. So while we are dividing 15, okay, divide by 2, so 7.5. Fine. Again 7 divided because decimal part we cannot take because it is divisible. And 7 3.5. So again decimal 0.5 cannot accept this. So this is the here 3. Right. And last, I will try to answer this. Let me delete this, and this is the remove. So I will tell you the precedence. Now this is the precedence. So precedence means what is the priority, how we are going to use. So in this priority we have to use, like I want to tell you the precedence so we can understand somewhat more. Fine. So we have here like this symbol, then we have like this symbol and this symbol, then we have ampersand sign and ampersand sign, okay, then we have here like first will be negation, not, first will be negation, and next will be here that is called as a XOR, and last will be that is called OR. So better I will use here comment, and in comment here I use comma, and this will be the comma, this will be again comma, and this will be comma, right? So here for example I'll take one example like m equal to here, like for example I am taking here 15 and n equal to like I have taken here 10. So this I can use, for example here this k equal to like we are going to use m, and here ampersand symbol this, and again n, and next I will take or, like or, and here I will take here m. Fine. So while and finally I'm going to print this, print the value of here k. Okay. So now we can understand here. So in this first precedence is here not. Fine. Second we have like left shift and right side. If both, so here it will apply the associativity left to right, right? And then ampersand symbol, and then here we XOR, then this or. So while I'm going to execute, so answer is 15. How answer is 15? Let me take this, I have to convert here so you can understand somewhat more. So I'll write here print. This print session will be here like M, and this I will better I will do, I will save my time. I will copy here like, so it will be easy for me. Okay, I can save the time. Like here I'm going to copy so we can understand this. Fine. So M converted binary, and this N also I have converted here binary, and K binary. Execute this. Okay. And now let us see here. So in this first precedence will be AND operator. So M into N, M and N here, while we are going to apply this. So this answer will be, and that is called as 1 0. Fine. Let me write here. So comment. So while I am going to use M and N, fine. So M will be like comment, M will be 1 1 1 1. Okay, and this here 10, so this it will be 1 0 1 0. So while this answer will be, while comment, this will be like we are going to apply. So this will be, and means here 1, this will be 1, and this will be no, this will be 0, and means here it will be 0. Fine. And this will be 1, and this will be 0, and this will be 1. It's clear? Next, while we have to going to use here OR. Fine. So OR for M. OR for M. So M, that is called as a M. Again, I'm going to use comment, and here will be M. So M will be 4 times 1. 1, 1, again 1, again 1. And this OR operator. So this answer supposed to be answer. Final answer will be like here. Here it will be 1. Like, let me write here. So here we are going to add this OR. This will be again 1. This will be this will be 1, and this will be 1, and this will be 1 here, 4 1. So finally answer we got here 15, right? So now I am going to end my session here. Once again, if you are going to face any doubt, any problem, please write in comment section so I can answer it. Thank you very much.